Good afternoon. We're going to continue talking about the angles formed by sets of lines cut by transversals. To give you a little advance notice, I preemptively went through and highlighted some key vocabulary words and color-coded based on those vocabulary words. So if at any time you need to pause to catch up to the highlighting that I've done, I would do so. So right now on the first, I just want to review. Right now we have vertical angles. Angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. Angle 5 and 7 are vertical angles. And angle 6 and 8 are vertical angles. Linear pair is also a vocabulary word that we've been using frequently. And so as I look at it, 1 and 4 are linear pairs, they lie on a line and they're adjacent. 1 and 2 are adjacent angles on a line. 2 and 3 are adjacent angles on a line, and 3 and 4. Now, the unique thing that happens when you have lines that are not parallel cut by a transversal is the vertical angles are the only angle pairs that are congruent, which is in stark difference to when lines are parallel. We get this nice result of multiple angles being congruent to one another within that system. Okay, pause if you need to catch up. Be sure to highlight or at least annotate the diagrams that you're writing down. So today we're going to use these ideas and concepts to sort of continue the discussion that you guys have had in the readers and the recent homeworks. And right now it says use the diagram below to help you with problems 1 through 10. I went through and I highlighted corresponding angles because I knew that was a vocabulary word. And it says identify all pairs of corresponding angles. Are the angles equal in measure? How do you know? Okay, so we'll first go through and we'll identify all pairs. What I'm noticing is that 1 and 5 are sort of located in the same vicinity of the set 4. And so angles 1 and 5 are vertical angles. 2 and 6 3 and 7 and angles 4 and 8. The way I like to think about it is if I took a pair of scissors and I cut directly between the two lines and then slid or translated the first group of 4 on top of the second group of 4 and what numbers match up. Okay, how do I know that they are equal? Corresponding angles are equal in measure when lines are parallel. So it's huge to know that we have parallel lines. We have a lot of results that we can infer because of that. And so this idea becomes super important. Right? You might want to pause the video just to update your definition of corresponding angles and then start again. Okay, in this situation, identify all pairs of alternate interior angles. Are the pairs of alternate interior angles equal in measure, and how do you know? Okay, and again, the assumption is that these lines are parallel and they're cut by the transversal M. So alternate interior angles, angles 3 and angle 6 is a pair of alternate interior angles, and angle 4 and angle 5 are alternate interior angles. So if I've given those as examples, I might want to go look to see where they are. And what I notice is 3 and 5 and 4 and 6 kind of lie inside of the parallel lines. And so what I like to think about is interior of a car, interior of a house, or the profession of interior decorator all has to do with things being inside. Okay? The result when we have parallel lines is alternate interior angles are equal in measure when lines are parallel. And again, the symbol is this double line. So again, you might want to pause the video to catch yourself up. Make sure you can define what alternate interior angles are. And that becomes really important. Continuing. We have the same image. I just copied it onto the paper for you guys. Went through and preemptively labeled and highlighted some things. So every time I have